Today we'll be talking about our new unit on equations and inequalities. We'll be reviewing 6th grade equations, which are called one-step equations. So these involve one step to solve. First example here we have from Fish Math is x plus 9 equals 14. So what we do to solve for x is we want to get x by itself. We call this isolating the variable. If we get x by itself, then it'll be x equals our answer for x. So we have to get rid of the plus 9 in order to get x by itself. This plus 9 is in the way. To do that, we're going to undo adding 9 with the opposite of adding 9. So the opposite of adding would be subtracting. So we're going to subtract 9 from both sides of our equation. You have to always do both sides in order to keep an equation true. If you just do one side, it wouldn't be true anymore. Say, for example, you said 2 plus 2 is 4. If you were to add 3 to just one side, then it no longer is true, because 3 plus 2 plus 2 would not equal 4. We have to add 3 to the other side as well in order to keep things balanced and actually equal. So we're going to subtract 9 from both sides like this. So a positive 9 minus 9 is going to make 0. Now there's no point of writing x plus 0. That's not necessary. It's just x. The plus 0 is just not a necessary piece. So this is what we call canceling out. A plus 9 and a minus 9 are opposites, so when we add them, they cancel out and they're gone because they make, again, 0. So 14 minus 9 would be our answer, which is 5. And that should make sense, because if you were to take 5 and put it back in the equation, 5 plus 9 is 14. We call that checking our work. So the answer here is obviously 5, as you can see on the right side. So the next problem here is similar, but a little bit different. Negative 8 equaling x minus 3. So again, we want to get x by itself. This time, the operation being done to x is subtraction. So to undo subtraction, we're going to do, again, the opposite operation. So the opposite of subtraction is addition. So we're going to do a plus 3 to both sides to get rid of the minus 3. And that will get this to just be x on the right side, because this will, again, cancel. One positive and one negative will make that cancel, which will just be x, which is what we want. And then negative 8 plus 3 is our answer, negative 5. Again, this should make sense. If you take negative 5 and you put it back in for x, negative 5 minus 3, if you were to kind of do the math on that, negative 5 plugged back in here, minus 3 would be negative 8, which is why the x here is negative 5. Let's try another example. So this one, negative 1x equals negative 10. Let's check that out. So you might see coming up pretty soon in your packet, you might see a negative on an x like this. That's the same as just negative 1x. So if you see a negative x, treat that the same as a negative 1x. You can solve them both the exact same way. To get x by itself here, we want to get rid of the negative 1 in front. This is in the way. We want to get just x, not negative 1x. So in between those two is a hidden multiplication. So we undo that with the opposite of multiplication, which is division. So we're going to divide both sides by negative 1. And a negative 1 divided by negative 1 is just 1. So 1x equals 10. So our answer here would be positive 10. Again, this should make sense because negative 1 times 10 is negative 10. So the answer that makes this true would be a positive 10. Let's see if we can get one with division. There we go. So for this one here, again, we're going to use the opposite operation. So x over negative 3 equals negative 3. So this time we have division because this is a fraction. So x over negative 3 is actually divided by negative 3. So we're going to undo that division by negative 3 using multiplication. So times negative 3 to both sides. Because when you multiply by negative 3, you'd have to use a fraction over 1. That would be negative 3x over negative 3, which would equal 9 on the right side. And a negative 3 over a negative 3 is really just 1. So 1x equals 9. Again, why does this work? Plug it back into the equation. 9 over negative 3 would be 9 divided by negative 3, which is negative 3. So the answer that makes this true would be just positive 9. So every time what we're doing is we're using the opposite operation of what's being done to x to get x by itself. So when it was being added to something, we undid that adding by subtracting. When it was subtracting, we used adding to both sides. When it was multiplication of a negative 1, we divided them both by negative 1. And then when it was division by negative 3, we did times negative 3 to both sides. That's how we do these one-step equations. It's just one step to undo what's currently being done to the variable to get the variable by itself equaling the answer that we need. What you're going to do next is in your packet, you're going to skip, so this is page 11 in your packet. So skip the top here. This is just some vocab that we've seen some of before, the coefficient and constant we've seen before. We're going to fill this in together in class when we get to it. But I want you to do page 11 here, the bottom 9 equations. So these equations right here. Okay, they are just like the examples I just went through. So go ahead and do those now to finish up this assignment.